All right, so back to the second part of the Zoom. So hopefully that was a very productive student independent learning time you had. All right, so parallel lines and transversals, going back to what we had before we left. So continuing on, just showing you what the top of the page looks like. So still talking about transversals. So you have two parallel lines cut by a transversal. So corresponding angles are congruent. So first off, we're starting with the lines we were looking at before with transversals. If you notice, they had a little bit of an angle, and at some point they would intersect again. But here we're starting out with parallel lines, and then we have a transversal. So here are some things that always happen when you have parallel lines cut by a transversal. So corresponding angles, and again, that's angles in basically the same corner, those would be congruent. Alternate interior angles are congruent, and alternate exterior angles are congruent. So all three of these would be congruent. Now, some of these are pretty obvious. Like if you have a straight angle and then you have that transversal, yeah, of course those would be supplementary. But here are some other things that would also be supplementary. So consecutive angles, that is angles on the same side of the transversal. Interior angles are supplementary. So like in this case here, like 4 and 5 would be supplementary. Consecutive or same side of the transversal exterior angles are also going to be supplementary. So in this example, it'd be like 1 and 8. 1 and 8, if you were to take those two angles like pizzas, take them out, put them next to each other, then you would have a straight angle. And so those are just some of the things, again, that kind of happen, that we know always happen whenever you have parallel lines cut by a transversal. Oh yeah, and from unit 1, remember vertical angles are always congruent. So like 8 and 6, you know, vertical angles means that they're on opposite sides of the intersection. And the angles that form a linear pair are always supplementary. So again, we still are using things that we had from unit 1. So well, that would only be like a week ago, more than a week ago, like, well, I'd like to say 2 weeks ago, but it's not exactly 2 weeks ago. But yeah, we're still using things from even back then. So that's why I tell you it's a good idea to have them. All right, I'm gonna move down here, and hopefully that would be enough for you to see. I think you can see the whole thing, yeah. So identify the angle pairs as congruent, supplementary, and then give your reasoning. So let's see what we have. So for A, we have angle 3 and angle 5. So angle 3 is down here, so that's on the upper part here. And from that, it is on the lower right. And then 5 we have right here, so that's the bottom intersection at upper left. So they're on the opposite sides. So 3 and 5 are on the opposite sides of the transversal, which in this case is not named. Sometimes it'll be like that. Sometimes they won't have a name like T or L or anything like that. So they are going to be congruent because they are alternate interior angles. So again, alternate interior angles are going to be congruent. So hopefully you got that information above us, because we're going to need that again. And that might be another piece of information that you might want to put in your notebook or keep a copy of, because I know when you turn in your packets, you're going to lose some of that information. All right, so next one, 1 and 8. So 1 and 8. Well, those would be supplementary. In fact, I actually gave that exact same pair of angles as the example for the supplementary example. So yeah. Anyway, let's see, 2 and 6. So look at where 2 and 6 are. Maybe I could kind of zoom in a little bit more. There we go. So 2 and 6. Upper right on each one. So those are going to be corresponding angles. Or wait, congruent. Yeah, they are corresponding, and that would mean that they are congruent. So 2 and 6, I mean, if you look at them, they look like they would pretty much be the same angle. All right, so 1 and 7, so we have congruent and alternate exterior. So 1 and 7. Alternate exterior, so I have my line that comes over here. Alternate, again, means they're on the opposite sides. So 1 is on the left, 7 is on the right. So that would mean that they are alternate. And then exterior, so if we look at this area, like if we can imagine this is the inside, well, they would be on the outside now. So that would be alternate exterior. All right, so next one, E. So angles 4 and 5. So 4 and 5, well, they're right next to each other. They're on the same side. Actually, that's the important thing, is that they're on the same side of the transversal. So being on the same side, that would make them consecutive. They're both on the inside, so that would mean that they are interior. So in this case, that would mean they are supplementary because they are consecutive interior angles. 3 and 7. So let's look at 3 and 7. Well, they would basically be in the same corner. So if they're on the same corner of each of their own intersections, then that means they are corresponding. And corresponding would mean that they are congruent. In fact, again, you can kind of just look at it and tell that they would be congruent. All right, next one, 5 and 6. So 5 and 6. So they would be supplementary or a linear pair. Because, well, they are a linear pair. So I guess that is one of the other options, because, I mean, they are, right? They're 5 and 6 are on this line here, the bottom of the parallel lines, and put them together. Well, they're already together and they make a linear pair. All right, sorry. 2 and 4. So 2 and 4. Oops. Well, they're on the same intersection and they're just right across from each other. So that would mean that they are vertical angles. Vertical angles, if you remember, are always congruent. All right, and let's get ready to go to the next one. So let's see, in this case here, if angle 1 measures 65 degrees, so that would mean this is 65 degrees. Find the measure of find each measure. So give your reasoning. So it looks like we have 2, 3, 4, 5, 6, 7, 8. And so we have to give all of them. So knowing that angle 1 is 65 degrees. Well, let's see what we can figure out from this. So angle 2. So 1 and 2. So looking at here, how would we tell what that is? Okay, well, we know that angle 1 and 2 being a linear pair would mean that they are supplementary. And supplementary means that they would add up to 180 degrees. So if we know that together, because remember, we know that this number 1, is 65 degrees, well, let's just subtract 65 from 180 and we get 115. And it even says right here that it is a linear pair. So that's one of the other things that has to happen with geometry, is you have to be ready to explain how you know, right? So how do you know? You might know, but you can't just say, well, I just know, or I have a feeling or something. No, that's not going to work. You have to explain exactly how you know. All right, next one here, angle of measure of angle 3. So here we have 3, and that would be 65. And if you look right across from 1, because again, angle 1 is the one thing that we know definitely. Okay, we definitely know that's going to be 65. So between angle 1 and 3, they are vertical. They're right across from each other. So since it's vertical to angle 1, then we must know that it is the same. All right, moving on. So number C would be, well, number C, part C, measure of angle 4. So what is angle 4? Well, in this case here, there's 2 things we could do. 1 and 4 form a linear pair, so you could pick that one as well. You could say that since they form a linear pair, they should add up to 180, and we know that angle 1 is 65, so this must be 115 also. But in this case, they went with a different explanation, and that is, well, we already proved angle 2 was 115. Since we already proved that angle 2 is 115 degrees, angle 4, which is vertical to it, that must mean that it is congruent. So those two would be the same. All right, next one, part D, measure of angle 5. And again, we should try to use 1 as much as we can, because if we use 1, that's the thing we know definitely, for sure, okay? Angle 1 is definitely 65, because anything that's a given has to be true. All right? If just in a really weird example, if something that is given turns out to not be true, then it's not your fault. Okay? It's not your fault. It's whoever's giving you the information's fault. So angle 5 is corresponding to 1. See how they're on the, again, if these were roads, they'd be on the same corner. So they would both be on the upper right, or sorry, upper left-hand corner. I have to remember sometimes my screen is backwards sometimes from yours, actually. All right, so let's go to the next one. Part E is angle 6, 115. Now, I guess we want to use a couple of different things, because we could say that it was corresponding to 2, but since we want to use some more of the vocabulary, let's go with alternate interiors to 4. So they're both on the inside and they're both on opposite sides of that transversal. So that would make them alternate interior. And we just have to go with 4 in this case. And we could pick some alternate exterior ones as well. So for angle 7, well, it's on the alternate. So 1 and 7 are on opposite sides of this line. And they are so wait, no, I already covered alternate. Exterior, yeah, exterior. So they're on the outside. So on the outside of those parallel lines. Well, they're on the exterior of that. So that makes them exterior angles. And measure of angle 8. So that would be, okay, so we know this is 115 degrees. And the reasoning they used with this one was it's a consecutive exterior to 1. So again, we're trying to use 1 as much as we can. So consecutive means they're on the same side. Exterior means they're both on the outside of these parallel lines. And again, we want to use 1 as much as we can because that's our given. So anything that's compared to 1 should be true. All right, so that's it for this one. I'm going to go ahead and move on to the next one. Actually, I'm going to go a little bit ahead just to see if there's an extra page or anything. And it looks like there is going to be an extra page. All right, now I'll give you a second or two to start writing this down. Whew. And that way, as I start covering it, it's not going to be it's not going to be like a whole bunch of extra writing. How much more time do we have? About 30 minutes? Oh, okay. Well, I'll give you a minute. All right, hopefully that was enough time. I'm gonna start covering them now. So same kind of example, or yeah, same exercise. So we have angle 6 here, and it's telling us that this is 142 degrees. So fill in the measure and give the reasoning. So number 6 we know is 142. So it's just numbered 1, 2, 3, 4, 5, no 6, 7, 8. So measure of angle 1. Well, 1 and 6 are across from each other, which means they are vertical. So angle 1 and 6 are vertical. So right there, vertical to angle 6. Now angle 2, so that would be this one here. And again, we're given 6. Well, they're right next to each other. They're on the same line, same transversal, same intersection, I should say. So 2 and 6, well, they are right next to each other, so they form an obvious linear pair, right? They're just from here, this line, they're just a linear pair. Excuse me. Angle 3, so let's see, this one would also have to be 142. It would be congruent because 3 and 6, right? They're on opposite sides of the transversal, so that means that they switch. Remember, alternate means like switch. So they've switched sides, they're on opposite sides, and they are interior between these two parallel lines. So alternate interior angles are congruent. All right, next one, well, we're looking at angle number 4. So that would be, let's see, down here. It looks like in this case, they didn't really go with, the number pattern looks like it's a little bit different than the other one. So number 4 in this case would be 38 degrees. And we know this because it's the corresponding angle to 2. And we know 2 is part of a linear pair. So going from the linear pair and then to the corresponding, that would be there. And there's a couple of other things you could use for this one here. But for this example, we're trying to use different ones. We're trying to use something that's a little bit different from one to the other. We don't want to just keep picking the same reasonings each time. All right, next one here. So part E is angle 5, which is up here. And since we were given 6, we could say 5 and 6 were a linear pair. But again, we want to mix things up a little bit. So we could say that it's also vertical to 2. It's a vertical angle to angle 2. All right, number 7, so angle 7, okay, so it says it's 38 degrees, and their reasoning is that it is consecutive and interior. So remember, consecutive and interior must add up to 180 degrees because they are supplementary. And lastly, angle number 8, so that would be 142 degrees because it would be consecutive. Consecutive again means the same side, so same side of the transversal. And 5 is on the outside of this parallel area, and 8 is also on the outside of that parallel area. So that would be consecutive exterior to angle 5. All right, so in this case here, for it looks like number 4 and 5, we don't need to really, well, we don't really need to explain the reasoning, because sometimes, you don't really need to all that much. But it looks like in example number 4, it looks like we have 3 parallel lines all cut by a single transversal. So I'm going to go ahead and move on down. Like I said, I gave you a minute or two to write these down. Ugh. Okay, so we have a given here. So if measure of angle 5, so that's this one here, and you could write 82 right there. Maybe it'll help. Or maybe you feel like you're good at remembering things and keeping things in mind as you move forward. So we know that this is 82 degrees, and it looks like our angles are measured 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But it skips 5 because 5 is up here. So there is no 5. It just goes from 4 to 6. All right. So angle 1. So now, again, 5 is the one that we have to keep in mind. You know what? On second thought, I'm not going to keep it in mind. I am going to put 82 right there. 82. Hopefully that's not too confusing. So angle 1 is this one right here. So, well, it's going to form a linear pair with 2, and then 2 is corresponding to 1. So if I know what 2 is, then I will know what 1 is. So what is left over here? So what we have to do is we have to go with 180. Oops, 180 minus 1. Well, we know that this is 82, so it's got to match there, and that would be 98. All right, so it just occurred to me that you may not be able to see this. But trust me, it's just 180 minus 82, so that would be 98, which is where they got this number here from. Now, since we already kind of used angle 2 to get angle 1, we already know what angle 2 is going to be. We already know it's going to be 98 degrees, so that takes care of that one. Angle 3, so let's look for angle 3, and sometimes the numbering on these is a bit weird, all right? So they don't always have to follow the same numbering pattern, numbering order, whatever you want to call it. Because in this case here, it looks like they're skipping across the top and then to each transversal. All right, anyway, 3, so that looks like this one, and this one would all be 98 degrees. And then measure of angle 4. So now we're looking at this one here. Now we know 5 is 82, and these are corresponding angles. So since they're corresponding angles, that would mean, well, they're the same. So 82. And actually with all of these, you can kind of tell that they're all either going to be 82 or 98. 82 or 98. Because again, we know that all 3 of these lines are parallel. That's what the arrowhead here means. We know that they're all parallel. All right, now let's go ahead and go here. So we got 6, and that would be 82. And you can pretty much just go with like the small angle. So like 6 is a small angle, that would be 82. 7, the next one here, 7 is also 82 because it's the smaller angle. And pretty much all of these are only going to be either 82 or 98. Angle 8, also smaller angle. 9, smaller angle. And now let's look at 10 and 11 and 12. So 10, 11, 12, they're all corresponding angles, so they're all going to be the same number, which in this case is 98. And there's a couple of other things too. You can look at the alternate exterior, the corresponding angles, all of those things. Because there'd be a lot of things to justify in that case if we had to state our reason. All right, I'm going to move down to the next one, number 5. Okay. All right, I'm going to have to get rid of these here. All right, so the measure of angle 12, so that's this one right here, is 121. The measure of angle 6, which is this one right here, is 75. Okay. So now we just got to go through each of these and kind of work each one out. So 75 degrees. So angle 1, that's going to be this one over here. Well, that one should be an easy one because those are vertical angles. They're right across from each other. 1 and 6 are going to be right across from each other. Even though there's 6 different angles, so you see how there's like 6 different angles here, it doesn't really matter how many angles there are. Okay, vertical angles are still going to be congruent, so that's how they got 75 here. So since we know this is 75 here, 75 there, well, it looks like we're going to have to try to find angle number 2. And that seems like it would be a bit of a chore. Now, one thing we can do is look at 5 and 6. that would match right here, angle 12. 5 and 6 add up to 12. So we know that we have 121 here, is what it comes out to. Angle 5, well, we don't know what angle 5 is, so I'm going to call that B. But we know angle 6 is one of our givens, that'd be 75. So what can I add to 75 to get B? Well, okay, well, you can just see it right there. 75 plus 46 is how you get 121. And I would just use some basic algebra here. And that's how they got 46 there, because they know this one. And even though there's another transversal cutting here, that it should still come out to 121. So that would mean that that's 46. All right, so I'm gonna go ahead and give it back here, 121. Angle 6 is 75, and this one is 46. Because even though we found 5 and 6, 5 is vertical to this number here. 2, 5 and 2 are vertical angles. Angle number 3. So we're going to kind of do the same thing. With if we were to add angle 2, angle 3, and angle 6, that would come out to 180. So how they got 59? Well, see what's missing from that. Right? They want to see what's missing from that. So that would be 45 plus 75, and then subtract that from 180, and that's how they managed to get 59. And you can start filling this out as you go along, because it's a little bit easier when it's on the diagram to look at it. And then angle 4 is vertical to angle 3, so that means that 3 and 4, since they're vertical, would be congruent. So they're both going to be 59 degrees. All right, a measure of angle 5, that would be 46 degrees. So let's see how they got that. Oh, it's just right across. 2 and 5 are 46. Now I could have put that one when I was figuring these two out to match that one. I could have put 46, and we could have done that sooner, because it probably would have made more sense to kind of like take it, kind of work towards what you already know. All right, and here 7 and 12 are vertical angles, so they would be congruent. So if this is 121, angle 7 is also going to be 121 degrees. And then here they got 59 by, again, making this add up to 180 and finding out what this number needs to be in order to add up to 180, because we have 121 right here. So that's how they got 59. So again, I'm just trying to show you how they're getting these numbers. All right, number 9, if I look here, 7, I'm sorry, not 7, what am I talking about? 6 and 9 are alternate exterior angles. Since they're alternate exterior angles, that must mean that they would be congruent. 6 and 9, so that takes care of that. So let's go ahead and find out how they got angle 10. And that would be 105. And this one is a little bit tougher, because to get this one here, angle 10 is the same as 2 and 3 put together. So that's 46 plus 59, and that's how they got 105. So that one's a little bit of a tricky one, because this transversal, you know, even though it's technically 2 angles, we know that they must add up to 105. And then let's see, angle 11. And then a lot of this is just going along. All right, if we know what 8 is, what was 8 again? So angle 8 was 59 degrees. So that would mean that 11 and 8 are vertical. So that must mean they must match. Angle 13. So again, those are vertical angles. So 10 and 13 are vertical. So that must mean it's going to be the same as angle 10, since it's 105 is angle 10. 13 is also going to be 105. Measure of angle 14, so that's going to be way down here. And if we know what 10 is, if 10 is 105, well, what does 14 need to be so that if I add it, it will come out to 180? Well, that would be 75. So a lot of this is just sort of like figuring it out from one step to the next step to the next step. It's really all this is. So using any of those properties, any of those relations with the transversal, yeah, I mean, you just kind of have to use a little bit of your problem solving again to get from one to the other. Now in this case, we have only one pair of transversal for number 6, and then, okay, so that would be it for this one here. So that will be it for today once we go over this one and the next one. And that would take us to the end of this lesson here. All right, so let's use our givens. Oops, I don't know why it keeps wanting to make me switch the line. Okay, angle 7. So what is 7? That would be 38. And angle 10 is 102. So I'm going to put 102 right here. Find each measure. So angle 1 is over here. So how did they get that? Remember, this is 102. Well, 1 and 10 are, well, they're on the same side. So that means corresponding. They are exterior, so corresponding exterior angles. And we know that corresponding exterior angles must add up to 180 degrees. So if we take 180 and we subtract 102, what the leftover will be is 78 degrees. So we know that this is 78. And we can still just keep going with that and fill in more as we go along. And we're trying to go in numerical order, although you don't really have to with these. You can kind of go, you know, if you know what some of these are, you can go ahead and just start filling them out. Like for instance, you would probably also know that 4 was 102, right? You can just go straight to that. You can look for any of the relations and just go, you know, what would be the same, and then just go with all the numbers or angles that would be the same as whichever one you were looking at next. All right, anyway, let's just continue just going down the line. So we already went, so we need 3 here. So 3 and 1, right? Those are vertical, so that's going to be the same. So that's going to be 78. We already did 4, so let's go to 5. So how do we know that 5 is going to be 38 degrees? Well, 7 is our given, and they are vertical, so that means that they would be the same. So 5 and 7 would be the same, so they'd both be 38 degrees. All right, measure of angle 6. So how did they get 142 from here? Well, 6 and 7 form a linear pair, so that must mean that 6 and 7 must add up to 180. If we know the smaller angle is 38, well, 180 minus 38 would be 142. For the next one here, 6 and 8 are vertical angles because you can see they're right across from each other, right on opposite sides. That means that they would be the same also. All right, angle number 9. So number 9. And there's a couple of things you could do with this one. For instance, it's corresponding to 1. Right, it's corresponding to 1, and you don't have to use the same ones they're using, because you could also use, okay, well, this is a linear pair with angle 10, so make them add up to 180. So that's 2 ways you can get 78 right there. Angle 11, 9 and 11 are opposite of each other, so that would mean that they would be vertical angles. So vertical angles across from each other are going to be the same measure. They're going to be congruent. All right, well, in this case, J, but we're looking at angle 12. That's going to be 102 because 10 was our given. And if we look at the vertical, that's 12. So 12 would be 102. So angle 13 would be this one here. And it looks like it would be alternate interior to this one. We know that alternate interior angles will be congruent, so we just drop that in there. And this usually gets a little bit easier as you go along because now you have more information to choose from. You have more possibilities of getting that information that you're looking for. 14, so well, okay, so if, let's see, this is 142. How did they get that? Well, we know 13 must also be 38. And 13 and 14, add those together, they come out to 180. So 180 minus 38 would be how much we have here on angle 14, which is 142 degrees. Angle 15 forms a linear pair with 14, so that'll also be 38 degrees. 14 and 16 are vertical angles, so that would mean that they would also, excuse me, be congruent. All right, so again, you're just sort of getting one step to the next, to the next, to the next, until eventually you have pretty much everything in there that you need. Okay, so final one, I think. I'm not sure if we'll have enough time to do the next one because we probably have like 5 minutes or so left. So in this case here, it looks like, well, let's look at our parallel sides first. So it looks like we have this shape here, and we have the upper side and the lower side parallel with each other. And it's giving us a couple of givens. So 2 is 41 degrees. I have to write that really small. Angle 5 is 94. And angle 10 is 109. Not the best writing, but hopefully it works for what I need to get done. And then I'm just going to go ahead and start working these out as best I can. So 86, where did they get 86 from? Well, it would be a corresponding to this one, right? 5 and 6 are a linear pair, so they must add up to 180. So that would mean this would need to be 86 in order to add up to 180. So now we know angle 1 is 86. All right, now angle 2 is a given, so we don't need that one. Let's look at 3. So 3 is 53 degrees. Oh, well, how do they know that? So angle 2 and 3 together, combined, should equal out to number 5 because, well, as a pair, 2 and 3 are corresponding to 5. So 53 plus 41 is how you get 94. And then moving on to the next one, angle 4. Well, we already know that that one was 86 because 1 and 4 are corresponding, so that must mean that one would also be 86. All right, measure of angle 6, what do we have? Where is 6? Oh, right here, right under this little number. Almost missed it. Maybe I'll zoom in a little bit on that one. Okay, I can't really zoom in on it. Oh, there we go. All right, and then we have number 7, which is this one here. Now 7 and 6 make a linear pair. So 180, 71 plus 109 is 180. So that one would have, well, that one was kind of an easy one. Let's go with number 8. So how do we know this is 30 degrees? Okay, well, we know 6 is 71, and we don't know 9, or we don't know this one. Actually, that one might be one that we'd have to go back for later. So if we were filling this out from nothing, we would probably not know how to get angle 8 just yet. So we'd have to go to find number 9, which in this case here, it would be alternate exterior to 2. 9 and 2 are alternate exterior, so that'd be 41. Now that would also be 9 and 8 would be corresponding to 6. So 6 is 71. If we were to put 8 and 9 together, it would still come out to be 71 degrees. So 30 is, we got that because 30 and 41, 30 and 41 make 71 degrees. So again, it's a lot of kind of adding, a lot of jumping from one idea to the next idea. So if we know this, then we should know that other thing too. Kind of like, I don't know if anyone really plays Sudoku anymore, but I know a lot, like back maybe 10 years ago, everybody played it because it was in the newspaper, and anybody who had a newspaper would have a Sudoku. But usually it gets easier the more you fill it out, because now you have more information to draw upon to get the next answer. Anyway, we got about 3 more minutes, so I don't think we're gonna have any more time to go over anything. I'm gonna go ahead and end the lesson here because I need to get ready for my second hour as well. So I'm gonna go ahead and get ready to stop the share.